So good evening, sir. Hello,
good evening,
sir.
ma'am. Good evening, ma'am.
Shall we start the session, sir?
Yeah, sure, ma'am.
Shall we start? Okay, sir. Thank you, sir.
Okay.
Good evening to one and all present here. It is indeed a great honor and privilege to welcome our esteemed guest, Dr. Durai Raj Vincent, sir, to this session. Dr. Durai Raj Vincent is a distinguished academician and researcher currently serving as a professor at the School of Computer Science Engineering and Information Systems, BIT, Vellore. With over 17 years of experience in teaching and research, including more than 9 years post-PhD, he has made sustainable contributions to the field of machine learning, computational intelligence, and network security. His research has been widely recognized, accumulating over 3,000 citations, an H-index of 27, and an I-10 index of 50, reflecting the impact of his work in the academic and scientific community. Dr. Durai Raj holds a Doctor of Philosophy in Computer Science from BIT and ME in Computer Science and Engineering from Anna University, Chennai, and BE in Electronics and Communication Engineering from Anna University. His academic journey has been marked by continuous growth, having been associated with BIT for nearly 16 years. In his current role as a professor, Dr. Durai Raj is actively involved in leading innovative projects in computational intelligence and cybersecurity. His expertise spans machine learning algorithms, data security protocols, and artificial intelligence-driven network defense mechanisms. We are truly privileged to have him with us today, and we eagerly look forward to gain insights from his vast experience. Welcome you, sir, to this session.
Yeah, thank you, ma'am.
Thank you, sir.
My slide is visible, ma'am?
Yes, sir.
Yeah. Yeah, thank you very much, ma'am. First of all, I would like to sincerely thank the organizers of a 6-day Atal FDP on advanced technologies for smart power systems. So I would like to sincerely register my thanks to Program Coordinator Dr. Mary Cynthia Regis Prabha, ma'am, who is associated with the Department of EEE from Nurul Islam. Also, I'd like to thank Dr. Ben Sujita, ma'am, who is from Computer Science Department from Nurul Islam, and all the organizers who have invited me for this particular presentation. So the topic I'm considering today for the discussion is applications of blockchain in energy management and trading. So basically, this particular workshop covers the major area of advanced technologies for smart power systems. So I guess most of the professors and the distinguished attendees are from the background of electrical engineering. So we will be in a position to discuss this particular thing. So good evening, one and all present here today. So let me start my presentation with this particular outline. So for the benefit of larger audience, we will have a detailed introduction to blockchain technologies and what are all the key characteristics of blockchain technology. And we will be slowly moving to the general issues in the energy management and trading in the present day scenario. And also we will be in a position to discuss about the role of blockchain technology in energy management and in what are all the various ways we will be able to integrate blockchain for the betterment of this particular field. And finally, we will be also discussing about some of the real world applications, especially in the developed countries where blockchain is widely used under this particular platform, along with the case study. So we will be able to conclude this particular discussion. So before we completely get into the blockchain-based environment, so let me give a brief introduction about the present day scenario, how the energy management and transactions are being carried out. So the energy management and trading relied on the centralized system. So we will be very much into a centralized system based scenario wherein which we will be handling all the operations through the particular kind of system. So this particular system may be controlled by the grid operators or utilities or even with the regulatory bodies. So, and most importantly, a manual reconciliation is what happening between the banks, energy providers, as well as the regulatory body. So, this is what the present day scenario. So, with this, if you look into some of the issues in the present day scenario with respect to the various point of view, if you look into the first one is the centralized control. So everything is in the centralized scenario wherein which we don't have much liberation with respect to the particular operation. So as we have already seen that the grid operators and utilities are controlling the prices as well as the distribution environment. And sometimes when it goes to the hands of private sectors, which may also lead to monopolies, which means we may not have much other options to go with. And second issue with respect to the present day scenario is the high transaction cost. So which involves the intermediators like brokers and billing services, which also increases the cost for the consumer. So it finally comes to the customers and the consumers part where in which the customers are in a position to pay a bigger amount for the lower utilization. So slow settlements when it comes to the payments and energy trading due to a lot of manual verification, which may lead to days of time in terms of settlements. And there is a possibility of energy fraud when it comes to the various companies who are participating in the power generation. So they may manipulate certain kind of things like green energy certificates, or there may not be much transparency with respect to all these processes. And finally, the lack of consumer choice. So consumers in present day scenario, they cannot choose what kind of energy they are using and from where it comes from. So all these kind of drawbacks we were having with respect to the present day scenario. So now we will be slowly moving to the concept of blockchain. So since most of the professors and attendees are from electrical engineering background, so let me give a detailed introduction about blockchain so that we will be able to easily understand how we will be in a position to integrate blockchain in the present day scenario in the field of energy. So blockchain is basically defined as a decentralized. So the centralization is a major issue with respect to the present day scenario. So blockchain itself is a technology which works on the concept of decentralization, a distributed ledger-based technology that securely records transactions across multiple computers in a particular network. So in a particular network or in a networking environment, it will be in a position to act in such a way that every nodes are equal partners with respect to that. So there is no centralized mechanism where one node will be monitoring and giving permissions for other nodes. So here all the nodes are equal participant when it comes to this particular architecture. So in this particular way, it eliminates the need for a central authority by using cryptographic techniques to ensure data integrity, transparency, as well as security. So when it comes to any particular transactions, any particular communication that happens through a networking environment, so which requires data integrity, security, as well as the transparency are the three important key aspects when it comes to any particular networking environment. So blockchain transactions basically recorded on a blockchain which are being called as immutable, which means we cannot make any changes with respect to that. Changes in the sense we cannot alter any particular information or otherwise we cannot even on the way deleting the complete information. So both are highly resistant when it comes to any kind of fraudulent transactions or any kind of an effort to tamper the particular information. So in that particular way, blockchain stands out when it comes to ensuring the security. So the term blockchain comes from the way data is structured and stored in a chain of blocks. So we will be in a position to see to that in a chain of blocks, we will be able to do that. So each block contains a set of transactions and is linked to the previous block. So there is something like data structure linked list. If we could recall, so how we will be able to store the address of the next node. So in that particular way, so here we will be storing the hash with respect to one block and another block. So there will be a continuous connection. So if any attempt to modify this particular hash, then the entire chain will be broken. So that's how we will be able to understand that it is just forming a chain, and any effort to tamper this particular information, so the chain will be broken and no longer it will be considered as a blockchain. So that's how the term blockchain has evolved. So how blockchain, basically we will be in a position to understand how it works. So transactions, whatever being initiated, it will be grouped into blocks, and each blocks are connected to the previous one using the cryptographic hash. So in the here we will be able to see to that this is how the blocks are being connected with one after another. So if there is a route to travel from 1 to 4, then it can be from 1, 2, 3, and 4. So any attempt of changes in terms of any particular block, even block 3 is being attempted, then the chain will be broken here and we will not be in a position to see any kind of chain which is being formed out of it. So what actually each block contains in a blockchain is the first is the transaction data. So whatever we want to transact with respect to that particular information, because this is not basically defined for energy or any particular thing. So as we all know that it was initially created for the financial transaction. So as we all know that Bitcoins and other things have been popular for more than 15 years. So initially, we will be concentrating on the transaction data, whatever data we want to transfer or send or whatever it may be. Then obviously the timestamp, whatever it may be, the time which is at which the transaction has been initiated or happened, that particular timestamp. And most importantly, the previous block of hash. So that particular hash or the message digest, whatever we will be in a position to create it. So that will be actually linked to the particular block. Then as usual, we will be including this nonce. So nonce is also one of the familiar word from the cryptography or network security. So which will be unique information with respect to that particular transaction. And we will be also in a position to look into the current block of that particular hash. So both information will be available with the previous hash as well as the current hash. All these will be available with respect to each particular block in this particular blockchain. So as we have already seen that why it is called as a chain. So here the particular example. So block 1 is being created with a particular hash. For example, A1, B2, C3 is the hash value of that particular block. Then when block 2 is created, so we will be in a position to see to that it is being connected to this. So the previous hash A1, B2, C3 will be connected to the new hash X4, Y5, ZS. So when the block 3 is being created, so this new hash, whichever created from block 2, will be actually connected to the next block, block 3, so that this will become the previous hash of that. So like that, we will be in a position to connect blocks of, or one after another. So if there is an attempt to change block 2, its hash value will change, which makes block 3 and all other blocks invalid because there is no chain movement available in this particular way. So nothing will be there because that's why we are in a position to say that this is the decentralization approach where each partner is equally responsible for that, which means every nodes are privileged here. Even one node is compromised. We will not be in a position to see to that all will be participating in that. So that's how we will be able to understand this. So what are the origin of blockchain? So we will be able to understand that cryptography, which is the base for any security mechanism when it comes to authentication, when it comes to confidentiality measures. So all these are applicable here also because we are bringing the security to another level and the basic computer science concept as well as economic principles. So because here the very much utilization of blockchain initially was only for the bitcoins or cryptocurrencies, what we would be calling. So in that particular way, it was being formed. So the foundation of blockchain technology was laid over several decades. So it was there even before several decades. So we will be seeing to that how it has been evolved over a period of time. So with a contribution from researchers from the various fields of cryptographic security, decentralized computing, as well as peer-to-peer networking. So that is what the foundation of blockchain. So which was the reason for the successful implementation of this. So when it comes to the origin of the entire blockchain concept, as we have seen that hash function, so hash function is widely used for message authentication when it comes to cryptography and network security. So there are several, so initially MD5, message ages 5 was the initial version of hash function. Later, we have secured hash algorithm of different bits, 128, 256, 512. So all these become the standard of hash function. So that same hash function, we will be able to use it here for ensuring the data integrity by producing the unique digital fingerprints of input data. So this is basically a data authentication process. So second origin is public key cryptography. So when it comes to cryptography, there are two types of cryptography or network security in a broader way we will be able to classify. One is a symmetric cryptography and another one is a asymmetric cryptography. So this public key cryptography belongs to asymmetric approach. So Diffie-Hellman approach, which was introduced in 1976, was actually the first public key or asymmetric cryptographic approach, which was used both private and public key for the transaction for both the data authentication as well as the confidentiality measure. So RSA algorithm was the very first algorithm which utilizes public key cryptography. Later, we have seen that several other algorithms also have been used that kind of approaches. So that is another base for this particular blockchain approaches. And finally, the Merkle tree. So Merkle tree was also developed in the year of 1979 by Ralph Merkle. So these kind of structures allow efficient and secure verification of large data set, which plays a crucial role in blockchain data storage. So all these concepts are very well utilized for developing a new technology called blockchain. So, what is the origin, how things have been evolved with respect to blockchain is, as we all know that blockchain was originally developed for the money transaction in terms of token and all those things. So it is the cryptocurrencies are the other name of blockchain even in today's scenario. So first ever attempt happened in 1983 by DigiCash. David Chalmers have introduced that DigiCash. It was a cryptographic electronic cash system that allowed anonymous transactions. So anonymously, the participants can participate in those kind of transactions. And then later, after 15 years, in 1998, there was another concept of bit gold. So yeah, it was actually in terms of gold. So which was name used before Bitcoin as Bitgold, a precursor to Bitcoin. It introduced a proof of work and a decentralized digital currency model again to this particular technological world. And later in 1998, another researchers have introduced B money, which is again talks about the anonymous distributed digital cash system, again using the cryptographic proof of work in terms of that. So this is how various efforts have been made by the different researchers before we arrive into that. So when this Bitcoin or the blockchain has officially launched, so it was launched in the year 2008 in the form of a white paper. So by a researcher called Satoshi Nakamoto. So he was along with a group of people, he has published a white paper called a Bitcoin peer-to-peer electronic cash system. So this is how a Bitcoin was introduced, and in vice versa manner. So we can understand that blockchain was also introduced, officially introduced in the year 2008, almost 17 years from now. So blockchain as a distributed ledger, a decentralized database recording all Bitcoin transactions. So it is a distributed ledger. So normally ledgers are there means we will be able to see to that only the centralized authority or one who has privilege, we will be able to see to that. So if a banker is there, only the banker can see the ledger of the transactions and all those things, and not every consumers or every customers can do that. At the maximum, they can see their own transactions. But in this particular distributed environment, a distributed ledger was introduced where anybody can see all the kind of transactions happening in that particular chain. So they will be able to verify, they will be able to see what is happening in that. So when it comes to the proof of work, a consensus mechanism, so which actually ensuring the transaction validity and the network security with respect to the overall uh, effort that is being carried out through blockchain, and decentralization and transparency, which eliminates the need for a central authority while maintaining the security. So here every single partner or participant is equally responsible for the overall process in term, because they are privileged to see and they are privileged to verify. So with all these efforts, in the year of 2009, a first ever Bitcoin transaction happened. So marking the official launch of blockchain technology. So this is what happened 16 years before. So blockchain is also having different versions. So first version from 2009 to present, as we all know that digital currency. So we can say that blockchain 1.0. So that is what the first version of blockchain, which was came in the form of Bitcoin, which was the first successful cryptocurrency, which inspires thousands of alternative coins. So now we can see to that thousands of alternate versions of that with respect to cryptocurrency, which is very, very popular. So even recent day, one of the famous publisher also has announced that all the reviewers who will be reviewing for their journal will receive the cryptocurrencies as a token of appreciation. So like that, it is being almost accepted worldwide, may not be in our country, but in a worldwide scenario, we will be able to understand that it has tasted its success in a very larger perspective. So the primary use of blockchain in this phase was as a decentralized financial system, as we can see to that this particular term is being very widely, because the original idea of such kind of things is in that way to break the barrier in terms of centralization of things. So blockchain 2.0 is the second version of blockchain. In 2015, it was introduced in terms of smart contracts and decentralized applications. So in 2015, Ethereum, which was founded by Vitalik Buterin, introduced smart contracts, which are self-executing agreements stored on the blockchain. So smart contracts is the one which will be taking care of everything. That's why we will be able to call it as a smart one. So it will be taken care by itself. That's how it will be able to store information with respect to the particular transaction and all the corresponding information. So smart contracts enabled decentralized applications and new financial model like DeFi, for example, decentralized finance, and which moves from just a digital currencies to another sort of applications, what we will be able to see to it. And the 3.0, the third version, which has started working from 2020 in terms of scalability, interoperability, as well as real world applications. So there were many real world applications have evolved in various fields by utilizing blockchain, because from 2009 to 2020, it was very much limited to the financial transactions and all relevant things. But from 2020, so the scalability is an issue with respect to any particular technology, any particular system, because when concurrent users are trying to use a particular blockchain, then obviously scalability issue will come, because how many number of users can be concurrently utilize that particular service, and interoperability between different systems. For example, if you are introducing blockchain to the hospital server, so how we will be able to see to that it works efficiently in that particular server, because it's a new technology and the server was used for so many years. So that kind of interoperability barriers have been broken, and there were introduction of several real world applications with respect to blockchain. So this particular 3.0 version basically focuses on solving blockchain challenges like scalability, speed, and energy efficiency. So new models such as proof of stake, layer 2 solutions, and sharding, which improve efficiency in terms of providing better scalability and speed of operation. And applications also started expanded beyond the financial transaction to supply chain environment, in from industry perspective, healthcare industry, hospitals, identity verification, and even for the government records, so where we will be able to have more security with respect to that. So some of the key characteristics of blockchain which ensures a huge success when it comes to its limited scope on various things. So first one is the decentralization, as we were talking about. So it operates peer to peer, where every participant or node has access to the entire ledger. So every participant is privileged here. No one can act like a boss or something here. So everyone is equal partners as far as, or equal participant as far as this particular environment is concerned. So there is no necessity to rely on the central server for anything to happen. Second thing is immutability. We cannot tamper anything. We cannot change anything when it comes to any particular transaction. Once a particular block of transaction is added into a particular chain, we cannot make any changes at all afterwards, because it will completely break the chain, which ensures the highest security, highest possible security to the transaction. So transparency, when it comes to transparency, we can understand that all the participants are equally treated in this. So definitely it is a transparent system. Everyone can see what is actually happening with respect to a particular network. So which ensures accountability for such kind of system, and also reduces the chances of any kind of frauds with respect to that. So when it comes to security, security is the sole idea behind the developing such kind of system. So we will here also we will be able to see to that. It uses cryptographic hashing and consensus mechanism to protect the data from the unauthorized alterations. So obviously it provides the best possible security to this particular system, and the consensus mechanism which will be ensuring the proof of all these particular transactions, and validations are very much possible in this particular way, that every time when a transaction begins or completes, the validation part will be taken care by this. So when it comes to the blockchain operation, so initially we will be initiating the transaction from a user perspective, which will be broadcasted to the blockchain network. So it is not a unicast, it is a broadcasting approach we will be able to see in this particular thing. So that's how we will be able to see to that it is being informed by all the users. So that's how we will be able to see to that. Validation of nodes is very much possible whenever there is a completion of any particular transaction. So block formation is the most important things already. We have seen that what a block consists of. So a valid transactions are grouped into block is one particular important step with respect to that. And every new block is validated and added to the blockchain using the consensus mechanism, whatever we have seen, POW or something. And finally, there is a ledger update of whatever happened with respect to a particular transaction. Again, the ledger is also distributed across the entire network for the proper verification. So when it comes to the types of blockchain, we have four types of blockchains are there. First one is the public blockchain, where everybody can participate in this. Everyone will be treated equally in that particular case. For example, uh, in a decentralized environment, Bitcoin transactions or Ethereum based contracts are being created. So that kind of things we will be able to take it as an example. So private blockchains also have, we have, for example, restricted access we will be having. Not everybody can participate. For example, blockchains are being deputed in a hospital environment or in a government sector. So definitely it cannot be available for the entire public. So only the patients and doctors or the government servants or one who avail the government services alone can have access to that. So that is what we will be calling it as a private blockchain. So consortium blockchain is another kind of blockchain, where a hybrid model where multiple organizations govern the particular network. So from the private blockchain, it is a extended version. It does not belongs to one particular organization. So multiple organizations can come together and they will be able to create a consortium. For example, if group of hospitals, if they come forward and they will be forming the consortium, then the patients who belongs to all these hospitals can have a hassle-free visit to those hospitals for their own problems and other things. And another hospital who is also part of that consortium can access the medical details through the secured environment which is being provided by the blockchain. And finally, the hybrid blockchain, which basically combines the public and private blockchain features for better flexibility and security. So if at all there is an effort to bring these two things together, then we will be able to call it as a hybrid blockchain. For example, a government may step into providing services through private things, then there can be a possible collaboration between private and public blockchain in that particular case. So when it comes to the applications, as we all know that it was primarily developed for cryptocurrency, Bitcoin, Ethereum, and any other digital currencies operate on the blockchain technology. So which we will be able to in a position to say that all belongs to this particular technology. Second one is smart contracts. So smart contracts is something we have been discussing, belongs to blockchain 2.0, where we will be able to execute all those things. So we'll be discussing about this in a detailed manner. So self-executing contracts. So self-executing contracts means the negotiations will be happening in an automated manner based on the predefined rules. So that is what we will be able to understand from that. And supply chain management. So supply chain management from industry perspective, when we are in a position to deploy blockchain in those particular case, we will be able to see to that there is an enormous improvement in terms of transparency as well as traceability when it comes to logistics. So logistics and tracking, logistics is a huge task when it comes to any big industry is concerned. So when it be in a position to introduce blockchain to supply chain management, it can track the movement of goods from origin to consumer. So in that way, it can be very much utilized. So when it comes to healthcare or hospitals or whatever it may be, so we will be able to securely store the patient records and medical data. So especially in the Western countries and other developed countries, so we will be able to see to that the patient records are being maintained across different cities, which means the patient can step into any particular hospital and they will be able to continue their treatments. So such kind of things will be very much protected with the help of blockchain. So it grants access to healthcare providers only with the patient consent, tracks who access the data and when, also ensures compliance with the data privacy regulations. So if there is a violation, so we will be able to backtrack and see that who has accessed and in what way. So even though they are part of that, are they really in a position to sell those information? For example, someone who is privileged to have the access, but they do not have privilege to sell or post those information to the outside world with the identity and all those things. So that kind of privacy regulations are being compromised, then we will be able to ensure that who has done that. And intellectual property and royalties with respect to the different artists and other things, so they will be able to utilize this for receive the fair compensation for their work. Retail and e-commerce can utilize this, which will be facilitate the trustless transaction between buyers and sellers. So they will be able to easily connect. Even recently blockchain was working between the consumer to consumer. So C to C environment, when consumers to consumer chains have been formed, especially with respect to selling the agriculture related products. So that was being introduced. And voting systems where we will be able to introduce a tamper-proof digital voting. There cannot be any violation when it comes to voting, and which may also enable community driven decision making, because voting is not always with respect to the election or something. So we will be able to understand the response from as a community or a society. So we will be able to apply this particular system, which will ensure appropriate solution for knowing the feedback from the community or the society. So with that, we can move to the next phase of key challenges in the traditional energy management, so which is our topic today. So I hope with that particular discussion, all of you would have got some brief idea about what is blockchain, how we can utilize blockchain in different environment. So with that, we will be able to move towards the next part of our discussion. What is the key challenges in the traditional energy management that we will be discussing as part of this? So as we have begun with that, so just we will be able to revise again that it faces several inefficiencies and limitations, which includes centralized control. So energy distribution in majority of the countries and states, it is a centralized control. Energy distribution is controlled by large utility companies, leading to monopolies and a lack of competition. So that's how the consumers or the users are not benefited, but the large utility companies are benefiting in a larger perspective, and the benefit of this particular industry is not shared to the consumers or the users. Second thing is, as we have seen, higher transaction cost, like intermediators like grid operators and energy retailers add additional cost when it comes to do that. Even in today's scenario, the power is being, even the state governments are buying the electrical energy from outsiders at different cost, so that everybody can relate it to it. And lack of transparency, so energy pricing and distribution data are often opaque, making it difficult to verify the transaction. So these are all the key challenges when it comes to the traditional energy management. So another thing is energy waste, which means the surplus energy from renewable sources like solar or wind is often wasted due to inefficient grid management. So that is another major issue when it comes to, because when it comes to solar and wind, it is being spread across the entire country. So the power generation is not restricted to few places, but majority of the places are being utilized for this. And cyber security risks are always there when it comes to the centralized energy grids, whichever we are maintaining in today's scenario, are vulnerable to cyber attacks, to all the information which is being there. So blockchain, with the introduction, whatever we have seen, we will be able to see to that blockchain addresses these challenges by decentralizing energy transactions, increasing transparency, and improving security. So it will be able to provide us a wholesale package when it comes to solving the issue from centralization to decentralization. Even it will ensure that the security, because blockchain is basically designed for the best possible security. So in that way, it will be ensuring that, and most importantly, the transparency. Even the users can see to that all the information is available to them. So, how blockchain can provide solution for each and every issue what we are able to see with respect to the traditional system. So, what is the issue we have seen as the first one is the centralized control and lack of transparency. So the issue with respect to the traditional system is energy markets are controlled by centralized entities like grid operators or utilities, leading to price manipulation and lack of transparency. So which can be very much addressed with the blockchain based solution in terms of decentralized peer-to-peer energy trading, which eliminates middleman, allowing direct transaction between producers and consumers with full transparency. So in that way, both the energy producer as well as the consumers can be directly connected, and all sorts of middleman can be eliminated, and which will also ensure some kind of transparency with respect to the whole process with this. And the second issue is inefficient energy trading and market barriers. So traditional energy markets are slow with respect to higher administrative cost and regulatory barriers, which prevents small scale producer from selling excess energy. For example, in my house, if I have the solar panel, so through which I will be generating the electrical energy, so I may not be able to sell, because it is a very small scale production with respect to a particular house, and it is very much restricted only to that particular house, and that's how we will be able to see to that. So when it comes to the blockchain based solutions, so we'll be able to see to that the smart contracts automate energy transactions instantly when predefined conditions are met. So for example, predefined conditions are met means we will be able to see to that if somebody else is actually in requiring some kind of electrical energy, and another house there is a excess energy, it can be usually shared between those two houses. So that's how we will be able to ensure that. So this particular smart contract on, otherwise it will be eliminating even the paperwork and reducing the trading cost that is being involved in terms of the paperwork and all those things. So, energy fraud and double spending in renewable energy certificates is an issue because some companies may fake the green energy claims or sell the same renewable energy certificate multiple times. So, that kind of issues can be very much addressed with the help of blockchain, where the distributed ledger is immutable. So, we cannot make any kind of changes with that, and we will be able to ensure that the renewable energy certificate is a tamper-proof one, and we will be able to prevent the double spending and fraud corresponding to this particular issue. And the next issue with respect to this particular industry is grid inefficiency and energy waste. So energy demand and supply fluctuation causes excess energy waste due to limited storage and inefficient grid distribution. So that is another issue with respect to that. So here we will be able to address this with the help of tokenizing energy. So one token is equal to 1 kilowatt of that particular energy, which allows real-time microgrid optimization, which reduces the energy waste through demand response mechanism. So all these are quite possible with respect to that. So this will actually eradicate the grid inefficiency when it comes to the distribution process that it does with respect to that. On the other side, it could save the wastage of energy, so which is very much needed in a country like India. And the cyber security related issues, as we all know that the whole process is being highly secured, and any kind of attacks on the power grids are not at all possible with respect to this particular system, because we are not going to utilize the centralized system where only the attacks are possible or attacks are being attempted to get through the things. But here, since it is decentralized, there is no particular centralized system that needs to be attacked. So that's how we will be able to understand that the cyber security based risk will be completely eradicated through this. So these are all the summary of the present day challenges from centralized grid control, which can be addressed to peer-to-peer energy trading. Slow energy transactions can be addressed with the smart contracts, which automate and speed up the trading. Fraudulent energy certificates, another issue where this blockchain based record will be completely addressing that particular issue, because it is always a unique one and which can be verified at any particular point of time. Energy wastages can be very well addressed with the help of a tokenization, when we will be able to assign that one token is equal to 1 kilowatt of this particular thing. And finally, the cyber security based risk, whatever we are able to see to it, we will be able to address with the help of the blockchain that we are going to talk about this. So in energy management, so we will be able to see to that this particular blockchain technology revolutionizing the energy sector by enabling decentralized, transparent, and efficient energy trading and management is what it could ensure by introducing it with respect to this. So when we are in a position to do so, the traditional energy systems which lacks all these will be properly addressed by introducing the peer-to-peer energy trading system. So this will not only eliminating the intermediaries, but also it will be improving the efficiency. So when it comes to the peer-to-peer energy trading, so that is what the important solution what we will be able to propose for the energy management. So here this blockchain enables a decentralized ledger where energy transactions between producers and consumers can be recorded and verified without any kind of intermediaries. The key components involved include some of the things what we could do here is households with solar panels or wind turbines can sell excess electricity directly to their neighbors. Smart contracts automate the energy pricing and settlement based on the supply and demand. So energy pricing in the sense it can be completely depends on the demand and supply. So when there is a high demand, there can be different pricing. When there is a low demand, there can be different pricing. So that kind of things can be automated. So especially during the winter and summer, we can consider. So in summer, the demand will be very high. When it comes to winter, the demand may be at low. So that way we will be able to balance it. Also, it can eliminate the need for traditional utility companies which are acting as a intermediaries that can be completely eradicated and avoided when it comes to this. So, smart grids and IoT integration is very much possible because we know that IoT based sensors are actually doing wonders in the many of the fields, especially here when we are in a position to do the recording of real time energy production and the consumption through the smart meters and IoT devices. So, we will be able to see to the balance between these two. And blockchain also ensures the secure tamper-proof recording, and it helps in grid optimization by reducing the energy losses and balancing the supply and demand at any particular scenario. So that's how we will be able to always relate. Otherwise, there should not be any connectivity between production and consumption. But after the introduction of these kind of smart meters and IoT devices, we will be able to relate both. That's how we will be seeing a lot of advancements in this particular field. So when we see to that there is a decentralized energy markets, so we will be able to see that individuals also can participate in this along with the businesses that we are in a position to see to that. So everybody can participate in this particular thing, and the trade of this particular electricity is happening through a real-time scenario which actually reduces the reliance on fossil fuels by encouraging the use of renewable energy sources. So when individuals, when households are encouraged to participate in this, there can be many more takers who maybe go with the solar panels and other kind of renewable energy sources instead of going for fossil fuels. So that will be actually reduces a lot of uh, it reduces even the way at which the global warming is boosting up. So how blockchain will be working in terms of tokenization, so which will be converted into always a digital tokens, because as we know that it will be working in that particular concept. So consumers can both buy as well as sells these tokens when it comes to this particular trading, because in both ways every consumer can participate by the exchange of tokens with respect to that. So again, it will be a transparency that we will be able to ensuring here, and always this particular system can be a verifiable one in terms of carbon credits and even the green energy certificates. So blockchain can by this way empower the communities who will be create manage their own microgrids, which are localized energy system that can operate independently or in a conjunction with the main grid. So whatever way they will be able to participate in that. On the other side, blockchain can even improve the transparency as well as the traceability in the energy supply chain, from raw materials in terms of oil, gas, rare earth materials to final energy products. And it will be also facilitate crowdfunding and investment in renewable energy project, because crowdfunding is one of the prominent application of a blockchain. So crowdfunding and investments can happen in the renewable energy projects through tokenization and decentralized finance. So here the participation will be so easy to happen, because it is not going to be no longer a tougher process, because just the exchange of tokens, they will be able to facilitate this, and they will be able to participate in this. In that way, this particular sector can grow multifold through these kind of efforts. So when it comes to some of the real world applications where blockchain is being implemented in the energy sector, so we will be able to see that several companies and projects have actually already using blockchain to enable direct energy trading between consumers. So one such thing is in USA is Brookline Microgrid, which is a local energy trading system allowing solar panel owners to sell excess energy to neighbors. It ensures that. Power Ledger is another project from Australia, which actually helps them to do the energy trading among the consumers in the real time basis. So that is another one where we will be able to see to that. And even blockchain is allowed to issue the tamper-proof credits, ensuring authenticity, because at any particular point of time it can be verified. And companies like IBM and Energy Web Foundation are working together on blockchain-based certification system, because this particular certification system is a complex process where the introduction of blockchain into the energy sector actually trying to work on this particular aspect, so how we will be able to automate these kind of things. So when it comes to the real world applications of blockchain in energy, so we will be able to see to that several projects have been taken in the past. For example, Energy Web Chain was created for renewable energy producers with the consumers globally. Tenet is another work has been done in Netherlands and Germany, where they have used blockchain to integrate decentralized batteries into the power grid by reducing the blackouts. That is another real world application. Electric vehicle charging and payments, where this blockchain is being introduced. So blockchain enables automatic payments for EV charging stations. So EV charging, if you are in a position to charge our vehicle, so based on the amount of charge we have consumed, we will be able to pay it with the help of corresponding cryptocurrency and anything. So this will be an automated process, and no manuals will be involved, manual efforts will be involved in this. So especially companies like Share and Charge and Changi actually uses the blockchain for real-time billing and transparent pricing of EV charging. So already they are into this particular action when it comes to do that. So benefits, definitely we can understand that the decentralization eliminates the need for central utility companies, empowers the consumers to buy and sell the energy directly. That is what the huge benefit, what we will be able to see through when we bring blockchain into the energy management. And second thing is transparency and security, which covers all the aspects of this when it comes to the immutable nature of any particular blockchain transaction involves there can be any kind of violations with respect to that. So cost efficiency is another important aspect when it comes to the benefit, because it reduces the transaction fees by eliminating all sort of intermediaries, as well as it automates the settlements using smart contracts. So there is no absolutely no manual efforts in all those things. Everything will be automated. So there can be a consumption, there can be a reading, and the payment also will be taken care automatically. So there cannot be any deadlines, there cannot be any manual verification, all those things. And sustainability and renewable energy growth can be improved if you are going to have this kind of system. So as we have seen that if you are involving all the individuals into this kind of process, so we will be able to see to that people will be encouraged to adapt to solar, wind, and other renewable sources into their households and wherever they have spaces with respect to the nature. So if there is a hot countries, they can go for solar. If there is a more wind flows like Kanyakumari district, so we will be encouraged to do these kind of things in a small scale manner. So it reduces carbon footprint by optimizing energy use, as we have seen with respect to that. So these are all the benefits out of it, what we will be able to see through it. And obviously, there are challenges and limitations. Definitely, no technology is giving any kind of free hand and utilizing it. So that's why we are going to see that despite its huge potential, so blockchain in energy management faces several challenges. So first one is the scalability issue. So we have seen that in the beginning itself. So when there are more and more users, concurrent users at a particular time, it will be very difficult to see to that a particular service will be available to all its users. So that is a huge issue with respect to that, because processing a high volume of transactions remains a challenge with respect to a blockchain. Regulatory uncertainty is always an issue because government lack clear policies on decentralized energy trading. Again, it is changing from government to government. Another major issue when we are in a position to bring these kind of facilities to that. And integration with the existing system is another major issue, because traditionally the particular sector have been working for so many decades of years when it comes to the whole process. So bringing some kind of changes and integrating with the existing system and the infrastructure will be something, a very difficult thing, which may sometimes demand a huge investment also for a platform change and all those things. And energy consumptions is also an issue with respect to the blockchain environment, because this particular network consume high energy because it basically works with a lot of information. So whatever the sustainability goal we were trying to achieve out of it, it may be actually contradicting to that particular goal itself. So that kind of energy is being consumed by these kind of blocks. So challenges and limitations always to relook into that, how this kind of things should be overcome when it comes to apply that. So, what will be the future of blockchain when it comes to this particular energy management? So, we will be able to see to that blockchain is expected to play a crucial role in this particular process, despite having a lot of limitations. We will be able to adapt to proof of stake for more energy efficient consensus mechanism, replacing the regular POW, as well as government and industry collaboration can happen in the future for regulatory framework supporting blockchain based energy market. Because as of now, the government and the industries are collaborating in a different manner, but when it comes to the blockchain, it may be benefiting the consumers in a better way. And in a larger perspective, integration of AI and IoT with respect to this is going to make a huge changes, because AI, we will be always knowing that we will be able to see what will be the future, what will be the future consumption. So how much amount of electricity is required in the month of May, in the month of June. So all these kind of things, if you are able to forecast accordingly, we will be able to start work. And it can be integrated, it can be automated. So those kind of things are very much possible. IoT based sensors will be always giving some sort of inputs where we will be able to connect AI with that. So which may take a lot of smarter solutions by integrating IoT and AI in this particular thing along with blockchain may do wonders in the future. So that is how we will be able to look into the future when it comes to the energy management. So we have been discussing about the smart contracts, so which is the base for the entire transactions through blockchain. So we have to look into that in detail. What is actually the smart contract? What are all the components in that, and how it basically works, and what are all the benefits we will be able to achieve through that. A smart contract is a self-executing program stored on a blockchain that automatically enforces agreements based on predefined rules. So we will be in a position to give predefined rules for all these things. So which will be an automated thing. So smart contracts eliminates intermediaries and reduce transaction costs. Also ensure the trust in various applications, including finance, supply chain, legal agreements, as well as the energy management. So that is what the role of smart contract. So the various components of a smart contracts involved, the parties involved, so who are all involved in that particular process, those entities have to agree on the contract terms. That is the first thing. Conditions and rules, always the predefined logic. We will be having if then rules. If X happens, what should be done? If Y happens, what to do? So all these kind of conditions and rules will be corresponds to a smart contract. Also, a smart contract consists of digital signature of the parties who are involved in that, and verifications will be happening to ensure the authenticity of the information. Blockchain storage will be there, wherein which the contract and its execution are recorded permanently, because we cannot delete or tamper anything. So that is what the beauty of this particular thing. So we will be ensuring that. And so decentralization execution, which actually executing all these things with respect to a smart contract is concerned. So the working mechanism of smart contract starts from deployment, where a smart contract is written as a code. Example, Solidity or Ethereum. We will be using it for that, and which is being deployed on the blockchain. So that is the first step. So there is always a triggering event corresponds to that. An external input or transaction activates the particular contract. Then we may go for the validation of that particular thing as far as this particular working mechanism is concerned. So once there is a validation, so we will be able to see to that the contract will be automatically executed. So whatever the transfer of assets or recording results or whatever it will be able to do, so that will be taken care automatically. And obviously the immutability. So we cannot change once it is deployed. The contract cannot be altered, or that contract cannot be deleted. So that is what we will be able to understand with respect to that. So what are all the benefits of this particular smart contract? So first one is automation, no manual verification, no manual authentication. All these things will be taken care automatically, and it will be ensuring the security with respect to the encryption of the stored data, and a tamper-proof transaction which happens here. The transparency with respect to the contract execution is all the parties involved with respect to a particular blockchain can verify that, can see to that, can verify to that. And cost reduction, because there is no legal or processing fees as far as this particular transaction is concerned, and comparatively a faster execution when it comes to the traditional contracts, which will be taking a lot of time because manually we have to do that. So the smart contracts in energy management is concerned. So peer-to-peer energy trading allows the smart contracts to have all the households with solar panels to sell excess electricity directly to neighbors. For example, Power Ledger from Australia, already we have seen that, which enables the real-time trading using blockchain. So automated billing and payments is very much possible with respect to smart contracts, because automatically bill energy users based on the consumption of electricity. So again, already we have seen share and charge, which actually utilized for EV charging payments, which was automated between the consumption and the payment from the user and the service provider. So that is another way we are able to benefit with the help of smart contracts. In terms of renewable energy certification, again, we have seen that verifies the carbon credits and green energy certificates using blockchain, where IBM is involved, such kind of products where the clean energy transaction certifications are being provided by that. And grid optimization and demand response. So we will be in a position to optimize the grid, depends on the supply and the demand. So that kind of things we will be able to do it. So smart contracts adjust the energy distribution based on the real time demand is what we will be able to see as an outcome based on this. It helps balancing the supply and prevent blackouts when it comes to this particular process. So we will not be in a position to see to that there are blackouts due to the shortage of power. So there will not be any power cuts. We will be able to achieve through this. And when it comes to this, we will be able to see several possibilities in a real world scenario. In a peer-to-peer energy trading, a home owner sells 10 kilowatt of solar energy to a neighbor at a particular price. The smart contract verifies the energy transfer via IoT enabled smart meters and transfers payment into cryptocurrency or fiat. So this is where the smart contracts are being deployed between the neighbors in terms of the utilization of power, as well as they will be able to even pay it. So it happens automatically and there will not be any negotiation, because based on the if and then condition, this amount is also will be decided by the contract. So there will not be any physical negotiation happening here, and all these will be happening automatically. So dynamic energy pricing is actually being done, depends on the demand and supply. So especially during the peak hours, the contract automatically increases the price to, for example, $0.2 dollars per kilowatt, and it may reduces to zero point 0.1 kilowatt during the off-peak hours. So with respect to energy certificate, maybe a wind farm generates 1,000 kilowatt of energy. A smart contract issues 1,000 REC tokens, which a company purchases to offset its carbon footprint. So which can be directly related to its capacity of generation. So that's how we will be able to see to it. So electric vehicle chargers, maybe a EV owner plugs with respect to a particular part, and if he consumes 20 kilowatt of that particular price, then obviously the deduction will be happening with respect to that. And grid balancing and demand response is possible if a factory agrees to reduce energy consumption by 10% during the peak hours, where the households are actually expecting that. The smart contract can automatically verify this the reduction and reward the factory with the $500 in energy credits. So such a way the factory can help the balance with respect to the electricity energy. So microgrid energy management can be done by solar panels and wind turbines, which may distribute energy to 50 homes. The smart contract ensures fair distribution and handles payment between the community members. So energy subsidy distribution can be given to low income households, even in country like India. For farmers, different tariff will be there. For households, different tariff, and for industries, different tariff will be there. So this can be considered for a low income household, maybe receiving a subsidy for that. So where smart contract will be verifying on its own
for the eligibility, and it will automatically transfer the subsidy amount for that. So that's how it can be smartly work on that particular issue. So carbon credit trading, a company reduces its emission by 100 tons of CO2 and receives 100 carbon credits. So that can be again very much possible with a smart contract by enabling IoT based sensors, which will be actually monitoring the emissions. And if there is a significant reduction, it can credit the particular company with respect to that. And household, which reduces the energy consumption by 15 percentage when it comes to the previous month, especially during the high demand months. The household may be rewarded with a particular amount of energy credits, which can be done with the help of a smart contract. And even decentralized energy auctions also can be happen. A solar farm may auction 1,000 kilowatt of excess energy. The smart contracts awards the energy to the highest bidder of and process the payment with respect to that. Again, this can be done in a transparent way. So here we will be able to see to that the blockchain platforms are plenty like Ethereum, Hyperledger, Polkadot, or energy specific blockchains like Energy Web Chain that we have already seen. So these are all the various platforms what we will be able to see. And IoT devices are very much required for all these applications like smart meters, sensors, and grid management system. Also, we are in a need of cryptocurrencies or tokenization for payments or rewards or trading, whatever we does in form of Bitcoin or Ethereum or even custom tokens that we will be in a position to handle it. So when it comes to this particular thing, when we look into the challenges and limitations of that, there can be bugs and security risk with respect to that. Legality issues, maybe there scalability issues, maybe there, and integration with IoT itself may be a very big challenge with respect to the implementation of that. So in the real time introduction of some of the blockchain based solution provided by Brookline Microgrid, as I have already pointed out in the previous discussion. So it actually produces a lot of solutions in the energy based industry, where we will be able to see to that there are impact like lower energy cost for consumers, more control over energy consumption for users. Decentralization reduces the dependency on utility companies, as well as it promotes renewable energy adoption by monetizing the supplies power. So these are all the impact of that. The impact of Power Ledger from Australia again works in the similar thing. It has impact in the country by increasing accessibility to renewable energy. It creates a transparent and fraud-proof energy market, and it reduces carbon emission through energy efficient trading. So these are all the impacts from this. And when it comes to Tenet and IBM, what we have seen while we discussed in Germany and Netherlands, the impact like reduces the blackouts by stabilizing the grid. So they have eradicated the power cuts and other things, and also optimizes the energy storage and distribution, and also encourages the electric vehicle owners to contribute to the grid. So all these are the impact of that. And Iberdrola from Spain is also another blockchain yeah, initiative for the renewable energy certification. So that impact covers the elimination of frauds and renewable energy certification. It also ensures the corporate sustainability goals are met. Also, it promotes investments in the clean energy sources. So these are all the impact of these kind of certification. So the basic structure of the smart contract in energy management basically maybe covers with respect to this. So when it comes to the practical implementation, if you are talking about, so it will be very, very important to implement this smart contract. So a basic structure of a smart contract contains function that actually automates the transactions when conditions are met. So that is how the smart contract is being done. So this contract stores the owner's address and allows the user to retrieve it. So that is how the coding is being done. And the basic blockchain security, which will be ensuring the authenticity of the sender. So whoever the one who will be actually initiating that particular contract. So that authenticity verification should be done based on that. So when it comes to the smart contract for peer-to-peer energy trading, so it will be done in such a way that we will be in a position to see to that the P2P energy trading users buy and sell the electricity tokens as we have discussed already. So when it comes to the list of energy which is being available, so seller's list will be available and set a price. That is the most important step when it comes to developing the code for the smart contract. And when it comes to the other side, the buy energy, so buyers purchase energy and payment is transferred automatically based on the conditions. So if then conditions, whatever we have been set for this. And events log transactions also should be transparently available on the blockchain. So that is how we will be in a position to maintain this. And the smart contract for renewable energy certification is another important part with respect to the smart contracts that we have been discussing about. So energy providers actually issue the green energy certificates using blockchain to prevent the fraud, because this is part of this particular exercise. So issue certificate is the major function with respect to that, which issues the blockchain verified green energy certificate to the recipients, whoever will be the participator of that, and it should be also a tamper proof and the publicly auditable document because in a blockchain environment everything will be available for verification by the all the participants available with respect to that. So these are all the three important smart contract efforts with respect to whatever we have been discussed about. So when it comes to country like India, it is not even being attempted because in many other countries itself, it is in the niche stage where it has to go a very long way with respect to that. But still, smaller efforts are being taken at a specific region, and people were able to see to that there were some successes out of this. So this is how we will be able to see to that in one way. We will be able to participate as a solution, a smart solution towards the power systems along with the artificial intelligence and IoT sensors, because when we are in a position to bring all these technologies together, so artificial intelligence, Internet of Things, as well as blockchain, so we'll be able to see to that there will be a bigger revolution which may happen in the future. So that's how we will be able to conclude this particular discussion. So these real world case studies, whatever we have seen, which demonstrate how smart contracts and blockchain are revolutionizing energy management by enabling decentralized trading, grid optimization, and renewable energy tracking. So all these are the major takeaway point with respect to the blockchain in energy management as well as energy based system or power systems. So the challenges such as regulation, adoption, and scalability, which remains even today, and continuous advancements in blockchain interoperability as well as IoT integration along with artificial intelligence will drive this particular effort of innovation further in the future. So that is how we will be able to conclude this particular discussion, because the challenges with respect to the regulations, so government based policies are the biggest speed breaker with respect to its progress. But we will be able to hopefully see to that some kind of advancements and some kind of relaxation with respect to this particular sector, which may happen in the future. So, which will also become a smart one like many other fields. So, we will be able to see to that as of now a smart solution which is readily available to take it up for handling further challenges with respect to this. So with this, I'd like to conclude today's session on this particular thing. So if there are any thing to discuss about this particular topic for any clarification, so we can discuss about this. So I'd like to again thank all the participants for your uh, presence for my lecture beyond your office hours. Thank you once again to the coordinators and organizers of this particular event.
Thank you very much, sir. Dear participants, if you have any doubt, you can ask. So can you unmute your mic and you ask your questions?
Sir, good evening, sir.
Good evening, sir.
Sir, myself, Satish Babu from Velu, sir.
Yes, sir.
So regarding, so already we have learned from a lot of things from your discussion. Very useful information, sir. So once again, can you repeat some regarding the how the developing countries benefit from this energy solution using blockchain?
Sir, developing countries definitely will follow the developed countries, sir. Some of the projects which are being executed in countries like Netherlands or United States or Australia.
Yes, sir.
So yeah,
Yes,
they
sir, I
have
wanted this kind of-
utilized. So when the utilization becomes a large scale,
Yeah,
so definitely the developing countries also will try to repeat the success story, because as of now it has several limitations. As of now,
yes, sir,
we
yes.
have several challenges
Because-
as being discussed.
Because so I read one article, a very interesting one regarding this blockchain. Because our India is one of the developing country, and we are in some problem. Is it, sir?
Yes, sir. We are not even into this particular thing, sir. We are working 100% in the traditional manner.
Traditional
So
manner, yes, sir.
yeah. So it will take a lot of time to take it up, because India will slowly catch up the developed countries' efforts. So it will take some time, sir. At least 5 to 10 years it will take to see to
5 to
that
10
these
years,
kind
sir.
of things.
Oh,
Yeah, definitely it will take, sir, because in those countries itself it is not in widespread. So it may take another few years for them to completely adapt to this. So once it is being done there, then obviously the developing countries, after seeing the success there, so they will be also trying to adapt to that. So once we are about to adapt this, it will be a very challenging task, as one of the point I have discussed. From integration with the traditional system, what we have been using for many years, will be a quite challenging thing. So for that, infrastructure and investment, so both will be required. So
Yes,
we
sir,
have
yes.
to wait and see, sir.
Yes, sir. And regarding, because last year, before 3 years, the AI is just we are the theory wise we are just studying. Now the AI is dominating in almost all the field. And,
Yes, sir. From 2020 blockchain 3.0, we have been seeing these kind of improvements. So not
improvement,
only
yes,
in
sir,
the
yes.
field of energy, in many fields, as I have mentioned in the presentation.
Present, yes, sir, yes, sir, yes, sir,
Yeah. So it will go a long way, sir.
Thank you, sir. Thank you, sir. Definitely
Okay,
more
sir.
useful information, sir.
Yeah, thank you.
Thank you, sir.
Thank you very much, sir.
Sir, good evening, sir.
Good evening, sir.
So, Sadish Kumar from Vellore, sir.
Yes, sir.
Sir, what are the future applications for blockchain in global environment, sir?
So blockchain, wherever we are able to apply this, either security. So first thing is the security. So it will provide the best possible security. So wherever we are in a position to provide security, like for example, as I have mentioned in the healthcare industry, where we will be able to provide the most security for the patient records and other things. So like that, it can be used for the security. And second thing is with the secure transaction, so we will be able to automate things. So like during my presentation, I have mentioned even for selling the agriculture products. So for example, someone is having a small agriculture land, so where they will be able to produce their own vegetables or their own products. So if they want to market those things, so they can be very well utilize these kind of things among the smaller community, and to reach a larger community, so definitely it will take a lot of time, sir.
Sir, is it AI integrated with IoT, sir, for smarter energy management?
Sir, if we integrate AI along with IoT in the energy sector, it will go to the next level, sir, because AI will be always helpful for forecasting. So when we are in a position to forecast, then we can even automate the generation. And IoT sensors will be very much helpful on all kind of measurements. So in real time, we will be able to monitor everything. So by integrating AI along with IoT, definitely will boost this particular sector to the next level, sir.
Okay, sir. Thank you, sir.
Yeah, thank you, sir.
Any other questions? Okay, thank you very much, sir. So on
thank
behalf
you,
of
ma'am.
Thank you,
Thank
sir.
you.
On behalf of everyone present, I extend my heartfelt gratitude to Dr. Durai Raj Vincent, sir, for delivering such an insightful session on applications of blockchain in energy management and trading. Actually, this blockchain technology is new to all of us, most of us, but your explanation of this technology from the basic fundamentals and gradually moving towards the energy management sector and trading helped us understand this technology and how it is applied in our electrical field. So thank you very much for this truly enriching session. Thank you for taking the time to share your expertise with us, sir. We deeply appreciate your presence, and we are looking forward for your future interactions with us. Thank you very much, sir.
Yeah, thank you, ma'am. Thank you so much.
Thank you, sir. So our next expert is also with us. I would like to welcome Dr. Ben Sujin, sir, to the session. Sir?
Good evening, ma'am. Can you hear me?
Good evening, sir. Yes, sir. I can hear you, sir.
Yes, ma'am. Thank you. May I start, ma'am? Or
Yes, you can start. You share the slides, sir. We can start.
okay.
So it is a great pleasure that I extend a warm welcome to another present here. So we are truly honored to have Dr. Ben Sujin Bennett, sir, with us today, who is a highly accomplished academician, researcher, and expert in computer engineering, specializing in robotics, artificial intelligence, and Internet of Things. With over 20 years of experience in academia and research, he is currently a professor at the University of Technology and Applied Sciences, Oman, where he also served as the head of the engineering department. Throughout his career, Dr. Bennett sir has contributed significantly to the fields of data analysis, IoT, and intelligent systems, mentoring students and leading innovative research projects. He has been associated with the Ministry of Manpower Women for over 17 years as a lecturer and register, furthering technical education and workforce development. Prior to his tenure in Oman, he held faculty positions at Sahradaya College of Engineering and Sun College of Engineering in India. His extensive expertise and leadership in emerging technologies continues to shape advancements in AI, IoT, and automation, making him a distinguished figure in engineering education and research. Today, we are much privileged to have him with us. His vast experience and deep knowledge will undoubtedly provide us with valuable perspectives and inspire us all. Thank you very much for joining us, sir. We warmly welcome you to this session.
Thank you, ma'am. Thank you for the detailed bio about me. And I would like to thank the management of the Nurul Islam University and Dr. Mary, if I am not mistaken, Mary Regis. Okay, thank you all. And I would like to thank all the participants over here. Hope my voice is audible to all of you.
Yes, sir.
Today, thank you, ma'am. Thank you. Thank you. So today, in this session, I would like to just give you a brief about IoT-based smart metering using Raspberry Pi. As a practical approach, I would like to give you some points how to do the wiring, how to do or how to create a kind of small sort of project, which I have did it over here. And before going into the application part or before going into the practical approach, I would like to give you a small introduction about what is IoT. Most of you are aware of that one, but still I would like to highlight some of the few points about IoT. And then I will be explaining about something about the Raspberry Pi. And also this is not new for people around the globe. I would like to give some critical approach. I will just take you to later to some of the important aspects of Raspberry Pi, how it has to be used, everything. Then how to interface the Raspberry Pi over the internet and with the sensors and some components which are related and some of the programs and the web interface at the end. Yeah. Unfortunately, we are in the virtual mode, so the practical as a real-time application, it will be a little bit hard for us. Why? Because we don't have such components in either side. Okay, so our presentation is going to be over the PowerPoints only. So please bear with us. At the end, if you have any discussion or if you have any questions, you may raise it off. I'm ready to support you and to clarify your doubts. Yeah, let's start. Okay. Introduction to IoT. Yeah, what is IoT? We all know that IoT is actually Internet of Things. By the name itself, we know that Internet of Things. And if you have anything, like for example, I believe that all of you may have a pen and a notebook with you now. And we call that pen and that notebook as an object. If that object or if that pen and if that notebook is connected with some sort of sensors, if it is connected with a sensor and it is connected over the internet, that sensor is connected over the internet and it is capable of giving some data and to respond to some of the control given over the internet, then we call that system as an IoT system, and that object is an IoT. It's a thing which is connected to that pen, which is connected to the internet. So IoT is very simple actually. The basic underlining idea, if you got it, then easily you can develop any kind of IoT applications in a easiest way. The term IoT, it actually refers to the collective network of connected devices. So the devices inside that particular system will be interconnected. It is connected with each other, and the technology that facilitate the communication between the devices and the cloud. Yeah, we know that the data, what we get from those devices are stored at the cloud, and between it can able to transfer the data. So this is a basic definition of IoT. Okay, there are 4 stages of IoT. So once we all know now what is IoT. Means connection of different objects or different sensors, and the data are being transmitted over to the cloud. It is stored on the cloud. Then from there, again, some processing is happening on the cloud. Then some action is coming back to your object or your devices. So this is what I can say. Little bit definition of that IoT. So now what is if you want to make an IoT application, you have to go through these 4 stages. There are 4 stages we have with IoT, any kind of IoT applications. This is actually, these stages are an outward stages, I could say. But internally, if you go into the architectural level of this IoT, it has again each stage is divided into again many different stages, different functional viewpoints. Many viewpoints are there. So, but these stages, what it is shown in the screen, it's actually an outward approach, we can say, about the IoT stage, or a basic basic layman approach, I can say. So the first stage intends to be the sensing stage. So any IoT application, this sensing is the backbone, based on sensors, based on the inputs comes from the sensor. The IoT system starts its work actually. So sensing is the important stage. That's the first basic preliminary stage, we can say, where the data are generated. So your IoT application is going to work based on data completely. It is going to work based on data. So where the data are getting generated, it's from the sensors. So that first stage is our sensing stage. Then once you have the data, now I mean sensor data, now this data has to be forwarded from your system, from the tailor end to the next place. Okay, so you have to forward that particular data. So that we call it as a gateway. So forwarding the data from the data, so what you collected from the sensors, then you have to forward it to the next stage, which is called as the processing stage. So in between, you have something called as gateway. That gateway should be highly efficient gateway. It should have fast processing hardwares, so that immediately the data can be passed to the next stage for processing. So forwarding is an important stage here. The data, so what you get from the sensors, has to be immediately forwarded to the next stage without any data loss or without any interruption. So we know that. I'll give you a small example before I continue to the next stage. A small example to tell why the data are more important here. Nowadays, you know that IoT systems are everywhere. Internet of Things is everywhere. AI is everywhere. And more critically, I can say that nowadays, in many countries, developed countries, they have IoT-based healthcare systems. So you need not to do, the doctors need not to take care of the patient, just the patient go inside. The system itself collect the information, the sensors will get the data. It is going to process your data and it is going to take an action based on the input there. So just imagine that if the data, the sensor is not working properly, what kind of emergency situation we may get it, what kind of loss we may get it. So the sensor, that's what I wanted to say, that each and every stages here are very critical and important. So once you get the the sensor data should be perfect, as I told you, error-free data. It should be an error-free data. So now once you got the data, then you have to forward the data. If you make a delay in that forwarding stage, if our hardwares made a delay there, then again there is the consequences are high here. Okay, for another example, I can tell that in now many countries they have like auto-driven cars there. There is no driver will be there. We know that Tesla is doing that one. Okay, if that car is going on the road, just imagine that a trespasser is just passing immediately, suddenly. As a human, we immediately will apply the brake, but as an auto-driven car, it has to get the data. It has to sense the person, someone is out just passing, and immediately it has to process it. It has to understand there is an obstacle, then it has to stop, apply the brake. You just imagine the stages, how many process are going on inside or behind it. So the forwarding stage, the data forwarding stage should be highly in a fastest way, I can say there. Okay, so why I'm stressing this one? When you develop any IoT applications, in a practical approach, when you develop any IoT application, each and every stage we should give the clear importance there. And selection of different sensors, selection of the gateways also plays a crucial role here. If the gateway is not appropriate to our applications, then again we will fail there. Okay, so now once you forward the data is going to the next stage where the data are processed to take some decisions. Okay, the processing is like to either it will store the data, or it is going to, after processing, the data are getting stored, or during after processing some action we are going to take, or some decisions we are going to take. That is what going to happen in the processing. In some applications, if you think like this, forwarding and the processing will happen in the same place. For example, now I have some set of sensors for a healthcare system. Let me say, I will give this example now. A healthcare system, I have some set of sensors. Now the sensors are connected to the gateway, and this gateway, it's just collecting the data and for forwarding the data to some server which is on the cloud. So now the processing happens on the cloud, and a decision will come from the cloud to the gateway. Okay, so this kind of processing is called as cloud computing. This is called as cloud computing. In some applications, we will have the sensor is connected to the gateway, and the gateway itself, it will process the data. It will not forward the data to the cloud. It will process locally, and it will take the decision there. So this concept is called as edge computing. Okay, so these two stages, forwarding stage and the processing stage in any IoT applications, can be together at one stage, or it can be separated in two different stages. If it is together at one stage, we call it as edge computing. If it is different, then we call it as a cloud computing. Then the last stage is action, taking the action. So using actuators. So the inputs are given through. Yeah, someone is speaking. Is it okay? My voice is audible?
Audible,
The
sir.
inputs.
It's audible.
Okay. Thank you. Thank you. The inputs are given through the sensors, while the output, we get it through the actuator. We call it as an actuator. In terms of robotics, we call the acting stage, or the final output stage, we call it as an actuator. For example, when you, yeah, I can say like a small example with again with the healthcare system. If you want, when you go inside a hospital, the hospital, it's completely based on IoT system, and it sends your body temperature, okay, and it wants to give you an injection. And if you want to give you an injection, the needle and the injection is the actuator. That is the final one, which is going to give the output. So, I mean, in the IoT system, okay. So these are the four different stages we have with any kind of IoT application. So we should aware in which stage what components, what hardware components I have to select. Okay, fine. Same way, we have four pillars of IoT system. So if these things are there, only we can able to develop or completely do any kind of IoT system. The first one is the device, the hardwares, we can say. Powerful hardwares are required here. I mean, microcontrollers, microprocessors. Okay, microprocessors are required, sensors are required, actuators are required. So different kinds of devices. Okay, gateways are required. Many gateways, actually, if you are going with industrial based IoT systems, then a powerful robust gateways are required there. Okay, so devices are also very much important. So now many countries actually or many industries, we can say, like they avoid going into IoT systems, and they follow the traditional system because of the investment there. So you should have a proper hardware, proper devices. So if you want to go for a high configured devices, then you have to invest more there. So this is one disadvantages we can, or drawbacks we can say, which we face in the developing countries like India. Okay. Then the second pillar is the data. We know that completely it is data driven. The IoT systems are data driven. There is no inputs from the human, or there is no interference by the human there. The data are collected by the sensors. So completely it is data. So the data, you have to secure the data. Security is important here, and data should be error free, and everything should be what I can say, like in a proper format. The data should be in a kind of good format, we can say. Okay, so if you have a kind of missing data, error data, or repeated data, redundant data, so this data, if you have, then the system will not give you the proper output. So the second pillar, it's actually the data. So we have to give concentration on the data also. The third one is the analysis. So analysis is a kind of action or processing, we can say. So after you receive the data, the system, what we employ to analyze the data, the kind of softwares, what we are going to use to analyze the data and to take the action. So that also we have to think about it. And this is another pillar. The last one is the connectivity. We know what is connectivity. Now there are different kinds of connectivities the IoT systems are using actually. It depends upon the applications you can go. Many they go with the Wi-Fi connectivity. Wi-Fi is actually long range, but the speed is a little bit less there. But people they go for Wi-Fi. Even cellular connections are also used. Now we can go with the cellular because 5G is already into the market. So cellular connection is can be also used. If you are going to have an IoT application with a short range, you can go for Bluetooth. You can go for Zigbee technologies. Okay, and also you have LoRaWAN. So there are different kinds of connectivities you have. So based on the applications, you can decide what type of network connectivity you should choose for the IoT systems. So these are the four different pillars we have in any IoT system. So I just crossed the four different stages and four different pillars of the IoT systems. Yeah. Now I would like to introduce what is a Raspberry Pi. Okay, let me just open my video. Okay, I'll just show you in my video the Raspberry Pi, how it looks. As it's same as in the picture. Okay, it is shown in the picture also. You can also see how the board, this is actually a single board computer, or we can say it is a microprocessor, we can say. Okay, this is a kind of processor which we can use for any kind of IoT applications. Okay, for the smart metering also, this system will give you, this board or this microprocessor will give you efficient outputs, we can say. Even if you are in the beginner level, you can go for Arduino based systems also. You may know about Arduino. Arduino, there are different versions of Arduino we have. So you can go for, if you are in a beginner level to develop any applications in IoT, you can go with Arduino ESP8266. There are many different versions we have with Arduino. Okay, so the next version is actually this Raspberry Pi. Okay, I prefer this Raspberry Pi for my applications. So because it is like a computer, it has many, the processing is also very good comparing to the Arduino, and many advantages we have. Okay, so if you are a little bit advanced, we can go with another kind of board which I will show you. Okay, this is which is not in the picture. This is called as the Jetson NVIDIA. Okay, if you are going with the artificial intelligence based programming in your IoT application, either in smart metering or whatever it is, you can go with this board. Okay, this is a little bit expensive, but still this will give you a lot of what I can say. It's really fantastic, this device. Okay, very fast way you can able to do the analysis. So if you have this one, this you can say, like, this will support you as a gateway and also the processing. So we can, if you are going for edge computing, this can be preferred. So if you are not going to forward your data to any of one of the cloud directly, if you are going to work with this one, so you may prefer this one. So this is another good choice for any IoT applications. Okay, so now let me just explain to you about the Raspberry Pi. Okay, just I'll give you some introduction about the Raspberry Pi, its pin details, and how it will work, all those things. I'll give you some details. Okay, so Raspberry Pi is actually, it's a low cost single board computer. It's a low cost single board computer. Usually, okay, not usually, it's mandatory. This works based on the Linux application, Linux based operating system, which we call it as a Raspbian OS. Even Ubuntu also can be used. Ubuntu also can be used here. Okay, so but mostly we use Raspbian Pi, actually Raspbian OS for this one. Okay, if you see in this board, behind the backside of this board, in this place, the backside of the board, there will be a slot for the memory card. You can able to put 32 GB or 60, minimum 16 GB is required actually for the recent release of the Raspbian OS. You can put the memory card behind this one. Okay, if you would like to see, I will show from the camera. Okay, I will show you. You can see this one. Okay, this is a memory slot where you can insert the memory card, the small memory card, you can insert it. And this memory card, inside this memory card, you can install or you can upload your Raspbian operating system. So this board, this computer should have an operating system. Okay, so that operating system is Linux based operating system. Okay, the what we use, it's usually we use Raspbian OS. In the initial days, in years 2016-17, to install the operating system into the Raspberry was a bit tough, but nowadays it is very easy actually. Even if you buy the Raspberry board, along with that, you will get that memory card. Inside, you will be having the operating system also. So once you put the memory card inside, and if you power on this one, okay, you will be having, this is the power board. Okay, if you power on this one and you connect a monitor using this HDMI cable here, directly you will see interface there, Linux based interface, same like our Windows. You will see a Linux based interface, and you can able to start writing your programming and everything. Okay, so some of the features we have with this Raspberry Pi is like unlike other boards, I can say. You can see in this place you have the USB ports, 4 USB ports you have, and these pins are called as the GPIO pins, general purpose input output pins. Okay, I would like to just specify some more points related to these pins, because this will be really useful in any kind of application. So these pins, actually there are 40 pins here, there are 40 pins in the normal boards. Okay, these pins are used as input and output pins. So if you want to connect any sensors, you have to connect to these pins here. So the data from the sensor will come through these pins. So we call this is general purpose input and output. And if you want to connect any output device like an actuator, now you can use these pins here. You can the same any pins, same pin can be used as input, or same pin can be used as output also. Okay, but at one at a time, that's it, one at a time. Okay, so these pins plays the important role. These pins plays important role in any applications if you are using this Raspberry Pi. Okay, so this pins has different conditions actually. Okay, this one we divide, actually we can categorize these pins into different categories. I can say like power pins, you will see here in this place. Okay, 2 and 6 we have here. One is actually 3.3 volt. Each pin has different I think like I have different configuration. Yeah, I will explain this one in the following slide there. Okay, I have the pin details there. Okay, so now it has GPIO pins, and then I told you about the HDMI. Okay, I told you about the HDMI. This is the HDMI pin, where you can connect. You want to have a monitor, or you want to have a screen or a display to see what's happening over there. So you can connect your display through this HDMI. And Wi-Fi, it has an inbuilt Wi-Fi directly, like your mobile phone. You can just start using the Wi-Fi here. It has inbuilt Bluetooth. And if you want to connect any Ethernet, if you want to connect a LAN cable, like a network cable, you can use this one. It's RJ45 here, the RJ45 here. And this slot is actually for the camera. If you want to connect a Raspberry Pi camera, you can connect in this slot. This is for the camera, and this slot is for audio. If you want to have sound, audio, or anything like a computer you want to connect, just you can connect it. Okay, so if you have a Raspberry Pi with you, you can develop a small computer actually as a pocket-sized small computer. You can keep it and you can put it in your pocket, and anywhere you go, you can use that computer. Okay, so such kind of advantages we have. So this can be used in many kind of projects, automation, robotics, and in any IoT applications. Fine. Okay. So now the role of Raspberry Pi actually in IoT applications. Most of the points I already covered to you. Okay. It supports, I told you, supports Wi-Fi, Bluetooth, Ethernet, okay, for any IoT devices. The Raspberry Pi, once again, you can see in the picture, the right side picture, the Raspberry Pi is given over here, okay. Many applications you can use or how to connect it, okay. And it already I told you, Raspberry Pi can work also as an edge computing. It means that it can act as a gateway to forward the data to the cloud. Also, it can work or it can able to process the data by itself, and it can take the action. That's what mentioned here, processing the data locally and reducing the cloud dependency there. So you can store the data into the Raspberry Pi itself and to process it and take the action there. Okay, so you can reduce the cloud dependency, but in case if you need, but not all the processing can be done in some kind of applications. Not all processing can be done on the Raspberry Pi itself. So you may need some sort of edge cloud computing also. So you can also forward, you can get the data, sensor data from the Raspberry Pi, and you can forward that data over the cloud also. So as I told you, the GPIO pins allows the integration with the sensors, actuators, and any kind of hardware modules you have. And we can use this Raspberry Pi to make smart homes, smart agriculture, and industrial automation. Actually, now in industrial automation, now Raspberry Pi and many kind of hardwares are used a lot. This also can be used means accessed from a remote location. Okay, you can able to open your Raspberry Pi using SSH or VNC VMware from some different locations. So these are some advantages we have with the Raspberry Pi. So people, that's the reason people prefer to use Raspberry Pi in the recent days there. Okay, so some common IoT applications, what we can do with the Raspberry Pi. I already told about smart home, smart agriculture, industrial IoT. Actually, IIoT is developing in a fastest way. If you are good enough and if you can able to develop applications for any kind of industries, using Raspberry Pi, really it will be attractive and it will be useful also. Drones, yeah, nowadays we develop a lot of drones using the Raspberry Pi and yeah, obviously robotics is actually nowadays based, many robotics applications people use the Raspberry Pi also. Okay, weather stations to monitor the weather, to understand the temperature, humidity, all those things we can use the Raspberry Pi also. These are some common applications, but apart from this one, we have many different applications which you can use the Raspberry Pi also. Okay, as I told you, you can see here the details of the different pins here. I already just showed that GPIO pins, which is 40 pins in the previous slide. I'll just go to the slide. This is the GPIO pins, the right side. You can see here. This is the GPIO pins. So you will be having here 40 pins here. Okay, so GPIO is general purpose input output pins. So these pins are the I can say like a backbone on this board. So where you will get the data from the sensor, where you will give the output also here. So this is actually the main part of your Raspberry board. But each pin has different functions, as you can see in the PowerPoint. Okay, so there are two different voltage levels you can give. Okay, direct current only, not AC. Okay, DC voltage. The output of this will be DC. Okay, so 3 volt. Okay, 3.3 voltage. or you can give 5 volt. Again, you have one 3.3 volt. Okay, you can get output 3.3 volt or 5 volt from these pins from as the output. So we divide actually these pins into 4 type of categories, like power pins, ground pins, general GPIO pins, and special function pins. So some special function pins I can say here, you can see I2C. There is one pin called as I2C here. These 2 pins are called as special function pins, I2C. Okay, so we have 2 types of pins here, SDA and SCL. Some sensors actually it gives the output in the serial communication or serial bits there. We use these pins, SCL and SDA pins, some kind of moisture sensor, even some sort of temperature sensors also. We use this SCL and SDA pins. So we call that pins are called as I2C pins. Okay, then we have another set of special pin here, UART pins. So TXD and TX and RX. If you want to send any data over a GSM module or something like that, this TX you have to connect to the sensors or that module's RX, and this RX you should connect to the TX of that particular module. Okay, so to enable data transmission there. So this is another kind of special pins we can say. And you have here MOSI pins here, SPI pins, and here also CE pins here, SPI pins. So these are special purpose pins, and you can see power pins, ground pins. In this place you can see ground pins, and apart from that all GPIO pins here. So when you do programming actually, okay, just highlighting this part here. So when you do programming, for example, if you say like GPIO dot GPIO dot, this pin is GPIO 4 dot output or out comma high means you will get a 5 volt here. Okay, you'll get a 5 volt here. If you say GPIO 04 dot output is low means, then you will get a 0 volt in this pin here. You will get 0 in this pin. Okay, so when you write programming, you have, if you want to give output, you should say that particular pin as high, and if you want to give low output or 0 no output means you can say that the output is low there. So that particular output, it will go into that particular pin there. Okay, now coming to here, when you do programming, okay, you can also find a difference here. I'm just going into a little bit of that practical approach there. Okay, you can see here just a small example. I will say, yeah, the same pin which I used here, pin, yeah, GPIO 4, but inside you can see it is 7. The pin numbers are counted like this way, starting from 1, it is 1. I will say here, starting from here, 1, 2, 3, 4, 5, 6, like this, 4, 5, 6, 7, 8, up to here it will come. Okay, so this board is shown with the 26 pins here. Okay, the recent boards are coming with 40 pins. Okay, so now when you write program, either you can say pin number 7 comma high, or you can say GPIO 04 comma high. Okay, so both will come with the same output, either GPIO 04 comma high or 7 comma high. Both are going to work on the same pin, but when you write the program, you should set the mode of this particular pins. So if you say that the mode as BCM, if you say the mode as BCM, then your programs should have these numbers, GPIO, this 17, 27, 22, these numbers. Or you can use, if you want to use these numbers, so mostly for simple projects, I prefer this number so that I will not get confused. I will prefer this number. So in that time, I will use the mode for the pins as board, BOARD, board. So if I use board, then I can directly use these numbers here. So if I say high, it will take 5 volt. If I say low, it will take 0 volt there. Okay, so this is how we have to write programs to give output. Okay, so to get the input, you can use the read keyword there, so that you will get the input from those particular pins. Okay, so pin details. So before we go into the any IoT applications using the Raspberry Pi, we should know about the pin details. We should know about the pins. Then only it will be easy for us to write the program, because we are going to play with the pins when you write the programs there. Okay, to if you want to get any outputs, or if you want to generate outputs, then for sure we need to know about the pin details there. Fine. Okay, then some another things also. I just spoke about the hardware part until now. Okay, what are the pins and everything. I just explained to you. Now, along with that one, we should also should understand that this is based on some programming programs, actually, some sort of softwares we have here. Okay, so what are the programming is actually used is the basic one is Python. Now you all know that many people are aware like about Python programming. Many play it is used globally and everywhere we can say it is used. So now this Python programming, I prefer Python programming. I am developing the applications using the Python programming only. Okay, so Raspberry supports Python programming. It has its own Python interpreter called as Thorny interpreter. If you want to install any other interpreters also, it is very easy using a small keyword pip install, then you can able to install the libraries inside or the Python programming inside. You can go on. But if you prefer C++, yes, it's also possible there. Okay, and if when you not only we are going to develop some small applications, but so most of the time we go with the web-based applications. So if you want to go with the web-based applications, then we should you use this software Node.js and JavaScript. So if we have some idea about this one, very easily we can able to develop this web-based applications also. Yeah. Now, if some of the common libraries actually what we use with the Python is sorry, Raspberry Pi. Okay, so these are the basic programming. I explained about the hardware. Then the basic program what we are going to use, programming language is Python. If you know about the pins and if you know a little bit of Python programming, and down the library, if you know how to do the libraries or configure the libraries, then very easily within one day you can develop a small kind of IoT application with the Raspberry Pi. Okay, so some common libraries we use called as RPI.GPIO. This RPI.GPIO library is inbuilt, it is there. Just you have to import that library using the keyword import RPI as GPIO and as give any object name there, any name you can give there. You have to import that library. This library is used to control the pins. I told you before, you want to send output or you want to get an input through that pins, so you are going to control the pins. I'm saying that this pin is going to work as an output pin, or this pin is going to get to the input from the sensor. So I'm going to control those pins. So if you want to control those pins, you have to use the library RPI.GPIO. Okay, as I told you, you can able to set the mode as BCM, or you can able to set the mode as board. Okay, based on the pin numbering you can use there. Okay, and then another one library we have, which is GPIO0. This is actually a simple library. I can say it's not high level programming. If you are going with a low level programming at the initial stage, you can go with this GPIO0 libraries. Very easily you can able to, some built-in functions are there, so directly you can able to use those built-in functions, but this will not support you in high level applications. So always prefer RPI.GPIO library. So that will be like, I can say, moderate. We can say moderate. So most of the applications can be covered using those library. Then the last one we have, it's actually PIGPIO library, PyGPIO library. Okay, this is an advanced library used for pulse width modulation and servo controls. If you are going going to do robotics applications or drone applications, yeah, for sure you need this one, this library. You have to use this one because you have to control the motors there using pulse width modulation. Then only you can able to come or stop the motors with the precise locations there. So that in such cases we have to use this library. Okay, and this library also will help you to control your Raspberry Pi from a remote location, and in many real-time applications we can also use this library. Okay, so all these three different libraries, as I explained to you, which I explained to you, have what I can say, like a different use cases. It has different applications. So based on your application, you can choose the right one. Okay, and based on the complexity of your applications also, you can use the right one. So this is about the different libraries. So now the three things you need to have basically, okay, with the Raspberry Pi. One, the first thing is about the Raspberry Pi awareness or knowledge about the pins. First, you should have the hardware pins you should have. Then the second one, you should have the programming knowledge, a little bit of Python. Okay. Then the library, understanding about the common libraries. If you have these three things, then you can connect any sensor and you can able to develop any small sort of IoT applications using this Raspberry Pi. So that very simple applications you can easily develop with this one. Okay, so now let me just go into the smart metering. Okay, how we can develop this smart metering system using the Raspberry Pi. Okay, a small pictorial representation I have given over here. Okay, how it looks, how it, and we can see. Okay, you can see the Raspberry Pi over there, the different sensors connected over there, and a display over there. Okay, so this is just a pictorial representation. Okay, in real time it looks different actually. Okay, what is the purpose of this smart metering system is to measure the electricity consumption. Okay, and to monitor the usage patterns, like during which hours, the peak hours, and how the electricity is used. You can easily understand based on the IoT applications and enable remote billing. Like nowadays in our places, we know that the people, they go there and they take the billing and everything. But if you have an IoT applications, from a far place itself, you can able to, from the offices itself, you can able to start billing the energy consumptions in any IoT application. Okay. Uh, So in this one, in this one, we have different kinds of components. I'll just give you a small overview here. What are the components we are using it in this one? The Raspberry Pi, you can see here, the Raspberry Pi. Okay, this will act as actually the brain of your system. As I told you, this is the main controller. Okay, down it is actually this all as the extension of the Raspberry Pi. Okay, this will work as the brain of your system. Okay, this will process the sensor data and this is going to manage the communication. Okay, and if you need to send the data to the cloud also, this Raspberry Pi, as I told you, it will help. Okay, so now if you want to, when you want to transfer the data from the Raspberry Pi to the cloud, you may use some kind of protocols called as MQTT protocols. So those protocols will be used to transfer the data. And then we will be having here some kind of energy meter is there. Okay, you have the energy meter. This one will measure the electricity in real time. In this one, the energy meter will measure the electricity in real time. Okay, it provides the pulse output where each pulse represents a specific unit of energy, either it's watt or kilowatts. And this also provides, or it will help you to, tracking the energy on real time, tracking the energy, how much efficiently we are using, and also it will help you to provide the billing. Okay, this energy meter, you have to connect it to the Raspberry Pi through the GPIO pins. Okay, and two kinds of sensors we are using here. Okay, not actually two kind of sensor we are using for a simple application. These two sensors will be enough sufficient for any IoT metering system. But if you are going for an advanced system, then you should go with some another kind of sensors here. So here we are using two sensor. One is the current sensor and another one is the voltage sensor. The current sensor what we use here is actually ACS 712. ACS 712 is the current sensor, and the voltage sensor is ZMPT 101B. Okay, this voltage sensor is not available in many places actually. Okay, usually it's available in China. You can through online you can get that one. Okay, the current sensors will measures the real-time current consumption. Okay, so how it will measure, how to measure using the Hall effect sensing. Okay, based on the precise reading, it is going to calculate or measure the real-time current consumption. Okay, it will provide, this sensor will provide as an analog output actually. Okay, so I just missed to say something actually when I speak about the pins. The pins can some pins will accept the analog outputs, and most of the GPIO pins will accept the digital inputs. Okay, so you have to know about which pins will take, or the SCL pin, SDA pin, which pin will take the analog input. Okay, in terms of Arduino, if you speak about the Arduino as a controller, it has 5 pins which will take it as an it will take accept the analog input. Okay, so here just 2 pins, it will accept the analog input, so we should also aware of those things. Okay, this current sensor will give the output as the analog output. Okay, same as the voltage sensor also will gives the analog output. Okay, so apart from this current sensor and the voltage sensor, you can also have some another sensor like nowadays in the market another sensor is available like a power sensor, which combines the current sensor and the voltage sensor. So two sensors comes together, power sensor. Okay, but using this sensor is actually, I faced a little bit difficulties using these sensors in terms of programming. Okay, sometimes if the sensor is not in a good quality, we may not get the precise output also there. Okay, so better to go with the separate sensors there. And temperature sensors. Okay, if you want to understand the sometimes you will keep your system in a place where too much heat is there, or some more equipments are there in terms of industries I'm speaking. Okay, so you want to know the temperature, the environment is also there. Okay, the normal sensor we call it as a DHT11, DHT22 temperature sensors are used. It will monitor the temperature variation in the systems, in the environment. Okay, actually it uses a thermistor there. Okay, using the thermistor, it will understand the temperature and gives the input to our Raspberry Pi. So from there we can understand what is the temperature, and based on that we can able to take some decision also. Okay, so the same DHT22 sensors is used for humidity also. You can also calculate or measure the humidity of the environment there. So this sensor also can be used with your applications. So if you are going a little bit higher level, then you can go for MQ135, which is the gas sensor. If your environment is like more likely to hazardous, or more heated temperature is going to happen there. So in such cases, you can also use this sensor MQ135 as gas sensor to understand any unwanted gases or dangerous gases are available there. Okay, and you can go, you can add more sensors like RFID sensors, many sensors you can add to make your applications more, what can I say, more attractive or more efficient and more reliable. So you can go with more different kinds of sensors. Okay, so apart from this sensors, the next module we are supposed to have, which is called as the relay module. We know what is a relay module. Okay, to break your circuit, to switch on or off your circuits, we will use the relay module. Okay, even if you want to control your current comes, if you feel like some place the consumption is high, from the remote location you can able to automatically you can control it. So this is used for automated load shedding, power management, and also if you want to go with some emergency cutoff systems, we can go with this one. Okay, so these are the basic components, actually sensors and the hardware equipments, hardware components we need for this system actually. Okay, so now the same thing actually I explained here. What I explained is here the main components is the Raspberry Pi, the energy meter, the current sensor, voltage sensor. Okay, yeah. Apart something which I didn't explain is the Wi-Fi module. Yeah, it comes with the Raspberry Pi itself, so we need not to care about it. Okay, and LCD or OLED. When we transfer our data over the internet through a cloud storage, yeah, we can able to see what's going on there using a web application or a mobile application. Okay, but on the system in the local place, if you want to see, you can use an LCD display or OLED display or even a touch screen. Nowadays the Raspberry Pi comes with a 14 inches touch screen, which is looks very nice actually. Okay, for any good applications you can use that one. A bit expensive, but it is very good actually. It gives you an appealing feel for your application. So LCD and OLED are a small sized displays, but touch screens 7.4 inches and 14 inches are available nowadays in the market. You can use, or even you can go with a 15-inch monitor through the HDMI cables you can connect there. Okay, for a display. Then cloud storage. There are different types of clouds used. Nowadays, free clouds are there. AWS Azure is there. Microsoft is having its own cloud. Google Firebase is there. Okay, ThinkSpeak. I prefer ThinkSpeak actually. Okay, it's very easy to use. But when I go with the mobile application, I go for the Blink app, which is another kind of cloud storage. But these clouds are very I can say like little in space. Efficiency is a little bit low as we use as a open source. Okay, if you go for a real-time applications as an industrial based application, you can go for any paid one. AWS really it's good actually if you go with the paid one there. Okay, MQTT protocol, as I told you, this is a message queuing telemetry transfer protocol. This protocol is actually used for real-time data transmission. It's very fast, secure data transmission. Also, it has different I can say like different channels to send the data actually. So this will help you to fast data transmission, MQTT protocol. Okay, so these are the different components or different requirements we need to have when you are going to develop the smart metering system. Okay, another software requirements, I will just follow that one. Already I explained about the Raspbian OS, the operating system. The Raspbian OS is must here. Program Python should be there. Okay, then the if you are going to develop any web-based application, Flask is a very simple application, easiest way. In 5 minutes anyone can develop that application. Anyone can. Okay, there is no need to have any what can I say, kind of programming knowledge to develop a website using Flask. Flask is a very simple application, very easily you can able to do. But one thing you should have the understanding or the knowledge of connecting that database to the website, and that database to your cloud, your the place where you store your data. Okay, so that only knowledge is required there. So once it is there, easily you can able to connect your applications with any web interfaces there. Okay, and if you want to have like visualization, you want to see the in a graphical way, like the energy consumptions, the efficiency of those things, you can use those libraries or the tools called Grafana or Matplotlib. Matplotlib is the commonly used when you are going for the Python based applications. We use Matplotlib. Okay, Grafana is a little bit used, but Matplotlib is more sophisticated and it's robust actually. Okay, so these are the different softwares we need to know before we develop the metering application. Okay, so how to connect the hardware setup on the real time. Okay, a small wiring diagram I have just listed over here. Okay, you have to connect your voltage sensor and the current sensor to the Raspberry Pi GPIO pins there. Okay, GPIO pins here. And you have to interface your relay module for any circuit breaking operation and connect your LCD and OLED, and then the remaining things are completely inside your program. Okay, everything you are going to do in the program. Just I have shown you, given you here a small program here. Okay, a small program snippet how to compute the power. Okay, computing your power using P equal to VI. We know the normal formula. Okay, how to bring it into inside your program. A small programming snippet I have given here, which is used in the application. Okay, so using this one, we can like simply just with the two sensors, and you can able to connect. Okay, if you can able to read the current and voltage on the real time, then you can compute the consumption of the power there. Okay, and this program is actually at the end, it will write the files into an CSV file, a kind of Excel file. Okay, it's made in that way. So how much is used, everything is written, the power, the current, and the voltage is, it will be saved in the Excel file, and you can use it in the future purposes also. Okay, so once it is saved there, even you can able to do any analysis in the future. Okay, so small programming I have given to you. If you are interested, you can take a picture of this one and you can write this program. Okay, this is a working program. Okay, so then as I told you, if you want to transfer your data apart from your edge computing, usually we will do the processing everything in the edge itself, I mean in the Raspberry Pi itself. But still, if you are willing to transfer your data to a cloud, and from a remote place you want to monitor your system or you want to control your system, then you need to have the communication through MQTT. Okay, this protocol, you have to use this protocol, and to enable that protocol you want to have this programming code there. Okay, but the first set of programming will be enough actually. If you're going to develop the application in your local site, you need not to have any remote site. Means the first one is fine. Okay, but if you need to establish a communication over the internet to enable your application with the websites or mobile phone, then you need to have this kind of programming also. Okay, a small Flask interface is given for you. Okay, you can able to have you can have this kind of interface. This is actually Grafana is used to list the graphs there. Okay, but it is not that much efficient. Okay, I prefer always matplotlib there. Okay, so you can develop this kind of small interface so that you can, I mean, like, see what is happening inside your systems there. Okay, fine. Okay, and the data visualization we can able to do with this Grafana or matplotlib. Okay. Yeah. Okay. So controlling the relay module. I told you, just if you want to break your circuit or control or switch on and off any devices, you can use a relay. Okay, there are different channels of relay it is coming. If you want to control like 16 devices, 16 channel relay you can use. And also some programming lines which I told you before, GPIO.BCM set mode. As BCM, you may remember what was that, what those points mentioning that one. Okay, if you see here in the def switch off, defining switch off, GPIO.output relay pin, the pin is actually pin 18. Okay, now pin 18 means this is the GPIO pin, not the board pin. Okay, when you say here GPIO low, it means that pin 18 will get 0 there. So automatically the switch will get off there. It will go to the off stage here. Okay, if you want on stage, then you can use here high. When you give high, then automatically it will use. Okay, so here you can see the program here. in the loop. Switch on. So the switch is on now. Time dot sleep means 5 seconds it will on, then again it will off. Okay, GPU clean up means then everything whatever stored in that pins will be removed, whether it is high or low. So it will again start working from the program. Okay, so how to control the relay from remote. Okay. Okay, so the total energy can be calculated for your billing also using this method. Okay, and this can be written inside the program. This is actually can be written inside the program, and you can able to generate PDF bills. That is also possible with your software. Okay, with your Python program, you can generate PDF bills, and you can also send email, easily email, but SMS is difficult based on your, telecommunication regulations and all those things, but email is very easy, simple. Okay, so some features and benefits about our metering system is real-time power monitoring. On real time you can able to see remote controlling from a different location. You can control the electrical devices. So if you install this IoT system in your home from even for in case suppose you forgot to switch off your AC or switch off your fan, from your offices you can able to control, from a remote places you can able to control. Okay, so and it is not very difficult to develop such a system. Really, it is very simple actually. A small kind of investment is required, then you can able to develop this one. Okay, automated billing system which can be used by the government to make this one. Okay, cloud data storage. If you are storing the data on the cloud, the benefit is here is like in future, for future purposes, you can do the analysis. So once the data are stored on the cloud, you can able to do the predictive based on AI. Now AI comes here actually. You can predict what kind of how much amount of power will be consumed in the next month or in the next year. Okay, even predictive maintenance also you can plan. For example, if you are incorporating this one into any kind of transformers, okay, you can able to plan for predictive maintenance using these applications, IoT and AI applications. And also if you want to, if you're going not only with this normal power, if you are going with the hybrid power systems like wind power, or PV panels, smart grids. Okay, so such cases also you can able to do some sort of analysis like which power is giving more and how to control. All those things are really it will be useful with this cloud data storage and the IoT systems here. Okay, energy efficiency alerts. Yeah, if some thing it's exceeding that limit, you can set the alerts there so that you can control the energy consumed there. Cost and consumption analysis. So which area is getting most, it is consuming more, and how much cost it is taking. So all those things, it's really, it will make the life simple. If it makes the life simple, but the investment is high here. Okay, so these are some benefits of the IoT metering system. Then application. Okay, we have the different applications you can see here. Smart home energy monitoring. Okay, industrial power management. Mostly it is used in the industrial power management. Renewable energy, as I told you. Okay, it can analyze the solar or wind energy generation and consumption here. Okay, remote load control and automation. You can able to control control your power consumption from a remote place. Billing and tariff management is there. Okay, power quality monitoring. Okay, so these are different applications we have with the from using the IoT systems. Okay, so yeah, I would like to stop it over here, conclude my presentation, and if you have some queries, please let me know.
Dear participants, if you're having any doubts, you can ask. So if you're having any doubts, you can otherwise put it in your chat box. So we got so many feedbacks that the presentation that they liked your presentation, sir.
Thank you, ma'am. Thank you.
Thanks.
Thank you all. Thank you for joining this meeting, and thank you all.
Thank you, sir. So on behalf of Nurul Islam Center for Higher Education, I would like to extend my heartfelt gratitude to you, sir, for taking time to share your invaluable knowledge and insights with us. Step-by-step procedure explanation, your expertise in IoT, and starting from the fundamentals and gradually moving towards the smart metering application has provided us with valuable knowledge and virtual practical experience. Sir, we sincerely appreciate the time and effort you have taken to share your knowledge with us today. Thank you once again, sir, for your invaluable contribution. Thank you, sir.
Thank you, ma'am. Thank you so much. Thank you for the coordination. Thank you, ma'am.
Thank you, sir. Thank you, sir.